Hi, and welcome back to the data science course. This is part one, machine learning and data analytics. So in this lecture, we'll cover data sampling briefly. So we've already mentioned sampling a few times in some of the earlier lectures. And what we'll do as part of this brief lecture is that we'll mention some of the basic terminology and techniques. We'll not go into too much detail as we are going to use the machine learning libraries and their inbuilt functions for different types of sampling and handling the biases and the errors. And within that, we'll use k-fold cross-validation, which is a very good and efficient way of random sampling multiple samples in your data. We've mentioned the term population. So that is the set of possible values of the data being considered for analysis. So effectively, all the possible data that can be considered for analysis while building your machine learning model is the population. And now that can be quite large depending on the number of variables that are used to define that data, right? And what can happen is then while collecting that data can be quite challenging, right? I mean, you might not be able to even collect the entire population's data. And hence, you need to collect smaller subsets of that data which can replicate the behavior of the population and hence the data sample. So it is just a subset of the population which is then used to estimate its characteristics. So, it's quite obvious that the data sampling process is quite critical uh, when you are building your machine learning models because the quality of data impacts the quality of the models. I mean, the better the data, the more likely the model is able to replicate the population's behavior. And along with that, the more efficient the data sampling process is, the quicker and cheaper it will be to collect the data. So this is all part of the data science process. I mean, you want to make sure you can collect the data easily and cheaply. The sample size is the number of values in the sample which you can collect from the population to define its behavior. And that's just for one sample. Then you can have multiple random samples. There are two types of sampling techniques. One is probability and the other is non-probability. In the probability sampling technique, every element in the population has a chance of being selected at random in the sample. So when you are doing a sample collection, there is a chance that every value in the population can be selected, even though it's at random. However, in the non-probability sampling, there are some elements in the population which have no chance of being selected. So that's a non-random biased sample because you've made certain assumptions about the population based on which you're making the selection and you're eliminating certain values from the population. These are the kind of sampling processes which create the biases and the errors, and they're called sampling bias and sampling error, and they are the ones which can affect the accuracy of the model being built. So now let's look at sampling bias and error. Sampling bias occurs when some elements in the population have a higher or lower probability of selection, right? This is also called a selection bias. So see, we mentioned, right, that there are certain values which will not be selected when you're doing the sampling process. So by default, you are eliminating certain values. So it's a biased selection process. Now, what is that based on? We don't know, but they can or cannot be critical to the model being built to replicate the population's behavior. And these can then have future impact on the output values. Similarly, sampling error is caused by the difference between the estimated statistic from the sample against the actual parameter for the population. This is something we've already discussed, right? We've calculated mean squared errors, different types of error estimates. So effectively, your sample statistic will give you a value which will be different from the population statistic. You try and take the differences, take those errors, and then you try to minimize those errors to build a good model. And the way you can improve that is by using large number of random samples. With the larger size the sample, the better. Again, we've discussed this in the probability chapter. And finally, we have the non-sampling error. It's the deviation of the sample estimate from the population parameter, irrespective of the sample chosen. So you took a lot of random samples and still there is a deviation of the sample from the population. That can happen. and that is random or systematic, and it's very hard to quantify that. So these are those the small error terms which your model will most likely ignore because they are very difficult to quantify and can be quite expensive to incorporate into the model. Okay, so we'll end this data sampling lecture here, and as we've mentioned that this is going to be brief, and we'll rely on the machine learning libraries for the different sampling processes and techniques. Okay, thank you. And now we'll move to one of the most interesting and important parts of the entire data science lecture series, which is the data science process. How do you build the data science model given the data that you have? Okay, thank you.